Okay, my friends, let's break down this graph that you're looking at and see how it connects to these Jimmy Fallon Russian egg roulette games. Okay, the components of the graph. I'll start with this horizontal axis down here. The title is very important. Number of eggs to be smashed before a winner was crowned. Actually, that's a little bit wordy, but all that means is the game lasted that many number of eggs. So, for example, in the Peyton Manning Magic Johnson game, that was 5. That took 5 eggs, if you remember, to crown the winner. In that case, I think it was Magic. The least number of eggs it takes is 3. We established that in our in-class quiz this week. And the most number of eggs it takes is 11. You never have to smash that last egg. By the time you get to 11, you know who's won. Okay, so that's the horizontal axis. All possible number of eggs that it takes to have the game be over. Boom. Now, the vertical axis is a percentage axis. That's keeping track of what percent of the time that number of eggs was needed. So, for example, in the 3-egg case, this first column here, you can see that 11% of all of the games I watched took 3 eggs to be done. So either it went something like raw, or raw, hard-boiled raw. I think that's the only 2 cases that could happen. 6% of the time, it took 4 eggs. 6% of the time, it took 5, and so forth and so on. There's a very interesting kind of outlier at 8 eggs. I use the word outlier. We'll get back to that in this class later on. But there's that weird little spike at 39% right there. So that's the vertical axis. And I think I've already kind of wandered into the blue bars, which are simply 2-dimensional representations of the percentages. They start at 0 down here, and they go as high until they hit the percentage they represent. So that's a quick little bar graph introduction or reintroduction. We'll get into more of these as we go through the course, but I figured we could take a look at one right now. All right, go get the rest of the quiz.